Yes, students. So in last class we discussed about dynamic cast. Remember, everyone, students.
Yes, sir. Yes, sir.
Yes. Now in today's class we discuss one more small concept. Later on we start another concept. Now just we are going to discuss about casting and
downcasting.
downcasting. Know very well about this. First is upcasting and downcasting. Actually, upcasting, downcasting, both are nothing but it is casting only. But when you use this upcasting and downcasting means whenever we use the concept of inheritance, in that cases we are going to use this casting and downcasting. Compulsory, it must have the concept of inheritance. Inheritance should be there. Next is, because why I'm telling you inheritance means, inheritance only you can see parent and child, correct? Parent and child. Now here, what is upcasting? It's very simple. Upcasting is nothing but it is from derived to base. Derived to base. That is nothing but you are converting, you are casting from derived class to base class. Derived class to base class. That is called upcasting. Whereas downcasting is opposite to that. Base to derived. Base to derived. Base to derived. This is called downcasting. So upcasting is derived to base. Downcasting is base to derived. Now we will discuss about these two. About upcasting and about downcasting. See here, upcasting. Upcasting means derived to base. Directly I can say this is implicit. Is implicit because no need of using any casting operators explicitly to do this. So derived to base, it is like implicit because base is the parent. Derived, you are casting from derived to base means there is no problem. It makes sense. But whereas casting from base to derived means, so base class is having some functionalities, derived class is having some extra functionalities. So whenever you cast from base to derived, additional functionalities will come under derived. In that case, we get some problems. But whereas you are converting from derived to base means, so additional functionalities will be added to the base class. So then there will be no problem. But while casting from base to derived, so then we will get some problems. How means I will tell you with some examples. So that's why when we started discussion about dynamic cast, I told you dynamic cast is used for safe downcasting. See, if you don't if you don't care about, if you not more focus on this downcasting based to derived, we will get some problems. That is, what are those problems? Means we have seen it gives some undefined data. Otherwise, it gives, we need to handle those situations. When you handle, sometimes it returns zero. um, Otherwise, um, it raises some exceptions, and at same time we need to handle exceptions. At same time, whenever you want to get original data, what we have to do, we need to go back to the original data type. So we have seen many things, but especially one of the major use of objective of dynamic cast is it is providing safe downcasting. Safe downcasting means how it is safe downcasting. I showed you, I explained you with some examples also. But here we will do that again, but not with the dynamic casting. Actually, we need to discuss about this concept before uh, uh, dynamic cast only, but there is no problem. So now I'm going to write a few points regarding this casting. That is, basic one is derived to base, there is no problem. And next, when it is allowed, it is allowed in inheritance. Allowed in inheritance. This is a default, that is implicit. Already I have written this. To do this, I will take one example. With that example, we can justify this statement. I will take two classes. Class A, this is a parent class. Class B, this is child class. Both are having some properties. Void show, see out. See. And then I'm using a one more property. So this is, I'm taking display. I am from class B. So now what I do, I will create, first I will create objects for both class A and class B. Class A object, class B object. Two objects. Just every time I want to display the type information. See, type ID, it is one of the operator from RTTA. Remember, students? S of A is S of will see this. Type of A is class A, type of is it is class A, type of B is class B. These are the addresses. Class A addresses, that is object A addresses. This is the object A address. This is object B address. Type of A is capital A. The type of is capital A. Good. Now what I do, I will create a pointer variable for both capital A star P A. That is pointer for base A class, base class, star pointer for B. Now I can take this too. Now I am displaying type of PA is PA, type of PB is PB. We will see. See, pointer for A, pointer for B. Very good. This is for pointer for A. This is for pointer for B. Okay. So now what I'm doing? So now I will typecast. I'm doing upcasting. What is upcasting? Upcasting means you are converting from base child class to derived class. Child class to derived class. So child class to derived class means I can store. I will show you. Star PA is equal to what I am doing. Star PA is equal to address of P. Star PA is equal to address of P. See whether it is allowing or is it showing any runtime. What is that? Operand, no match operator, operand type capital A and capital B. It's a base one only, no? Otherwise, what I do, put here only directly. We will see. What it is showing, cannot convert B star to A star. Why? It is upcasting only. Derived, I have created object for derived. derived is B only. I'm storing the result into, yeah, base pointer value is A star. Okay. Anyone? Is there any problem? Nothing, no? Type info.
Sir, Shorish is saying you didn't inherit.
Oh, sorry, students. Sorry. I forgot to include that. No, sorry. I'm extremely sorry. Sorry. I've added that. Sorry. Sometimes if I do these small mistakes, you please, students, no problem. Or PA is equal to percent B. Yeah. Now again we're getting same problem. Public A. Okay. Now if I do this, now okay, it is allowing. Now if I see what is inside, see out, PA is, what is PA? PA is PA. What is PA? PA contains, yes, PA contains the address of the B. Very good. It means it is giving proper value. Whenever you are getting, it's giving some return, some value, new data type. So then we come to know about it is a valid. So now here what you are doing, you are converting. That means you are storing this ampersand B into base pointer variable. Means what does it mean? It is typecasting. That's why I told you. This is like implicit typecasting. It is implicit only. Whenever you do upcasting from derived to base, automatically it will take implicit typecasting. So that's why. So automatically, see here, you can store address of the object into base pointer variable. So then, if you want to, now the derived object is typecasted to base class object. Now, if you want to see what is inside PA, help of PA, what is the object of this PA? What are the contents? It's a base class now. Oh, it shows. Okay, sorry. Should be public. That's why it is not showing. So you must use public. Then you can see here PA dot, where you can see show method. Yes, it's a pointer. That's why instead of using this, you must use arrow operator. Arrow show method. So I'm from class A. Yes, because the derived object is typecasted to base class, where you can see base class object. Here there is no problem. And this is upcasting, nothing. See, unknowingly only we have done all these things. Like always, we used to create object for child class, and we can cast from child class to base class. We can use like this. Then there is no problem. So anyone is having doubt regarding this? Nothing here. It is implicit only. Students, anyone is having doubt regarding this?
No, sir.
Clear?
No, sir. Yes, sir.
Clear. Yes, yes. It's very simple. That's why I told you it is implicit. So now, if you go to the explicit, see, alternatively with the dynamic cast also we can write down. How you can write down dynamic casting? I don't know whether you remember or not syntax for this. Dynamic underscore cast A star. You can write down like this also. A star address of B. Both are same actually. This is dynamic casting. Both are same. PA1. So with the dynamic casting also you can write down like this PA1. See, here we are doing casting explicitly, correct? Explicitly by using dynamic cast. But for upcasting, no need to do. But already I told you, one more major intention of using this casting operator is it has to give more readability. That is very, very important. So here users doesn't come to know about CS we are doing here typecasting. But by seeing this statement, definitely users come to know, yes, we are doing typecasting from base to, derived to base, correct or not? So here in this case, if you use like this, it gives less readability. That is very, very important. Less readability. And here it is having a more readability. So that is, it's very simple. Now we go with downcasting. Downcasting. So just what I do, just I'm storing the address of base class object to derived class. First we'll see whether we get or not. Get errors or not. Now you see this. What it is showing, expected initializer before capital O. Sorry. Yes, you please see this, students. Invalid conversion from A star to B star. Okay. This is invalid conversion. Invalid conversion. See here, you are getting an error, correct? You are getting an error. Here, whatever you get, now I will do one more thing here. You please see this here. I'm taking B star PB1 is equal to dynamic underscore cast of B star. I'm storing address. Okay. You please observe the difference between these two statements. So now what I'm doing here, this is like I'm storing the address of A, that is base class to derived class. If I run this program with this, it is showing an error, that is invalid conversion, A star to base star. If I comment this and comment this, see here, if I use this dynamic cast in B star, like with the help of dynamic cast from base class to derived class, it will show you one error. What is that? We have solved this problem, correct? Source type is not students understanding polymorphic. Yes. See, because of this reason, what we did in last class, we have added one polymorphic. Polymorphic means, just I am writing here virtual. Virtual. If I add virtual, just we'll see. It will run the program. Observed? Hello? Just if the base class is having a virtual, it will run the program. It will run the program. But here it is showing some error. What is that? Finally, I can conclude that it will do at runtime, correct? But here it will do at compile time. Observed or not, students? Hello?
Yes, sir.
Yes. When you compile program only, it will show you it is an invalid conversion. But if you use this dynamic cast, what will happen? First, it simply show you it is not polymorphic. Once you add any virtual, so yes, it will run the program, but it will raise as an exception. How do you handle that exception? We have seen in last class only. This is called runtime. This is runtime problem. This is compile time problem. Okay, but at compile time only, it is restricting you. You should not do conversion from base class to derived class. Getting my point, students? So always, yes, this is downcasting. Downcasting is a problem. When you convert from base class to derived class means, yes, with one example I will show you. Int. Just you see this. Why we get that problem means, see, there is base class that is called person. Okay. Two derived classes are there. Yeah, these two are the derived classes. This class is student. This class is faculty. Okay. This is called base class. This is one derived one, D1. This is D2. See, when you do upcasting, up means, what is up? Derived to? Tell me, students. Hello?
Derived to base class.
Derived to base. Okay. Now you see, student. Student is a person. If I go like this, is student is a person? Hello?
Yes, sir.
Yes, sir. Yes. If you take D1, student is a person. If you take D2, D1 to base means there is no problem. D2 to base. Faculty is a person?
Yes.
No. Faculty
Yes,
is a
sir.
Yes.
Yes.
So this is yes, this is yes. Perfect. Correct or not? Upcasting. See, D1 to P. I'm taking D1 to P is nothing but it is an object. Just imagine. D1 to P, there is no problem. Yes, student is a person. D2 to B, yes, faculty is a person. There is no problem. Whenever you take a downcast, this is very, very important. You see here, P is a student. In this case, you please see. Is P only student?
No, sir.
No, yes. Person can be a student or
faculty.
faculty. Okay, no, getting my point.
Yes, sir.
Here we have a perfect concept. That is, a student is a person, faculty is a person, because of it is a relationship from derived to base. So whenever you casting from base to derived, then we get some problems. What is that problem? Is theoretical. I am explaining you. If I use P implies S means, is P only student? No. P can be a student or faculty. Same thing, P implies F. Is P only faculty? No. P can be a faculty or student. Getting my point?
Yes, sir.
So that's
Yes,
why downcasting it is a little bit difficult. We should take care about downcasting. If you use directly like this, when that's why here I'm storing the address of A into this PB. That means base class object, address of base class object into derived class. If you use like this, it rises compile time only. Compiler, it is restricting user to do not do conversion from base class to derived class. So at compile time only. But when you use dynamic cast, it will allow you. But you should handle those exceptions properly. Otherwise, it gives invalid data. We have seen in last class, remember. That's why safely downcasting. Safely downcasting. Okay, students? Understood this?
Yes, sir.
Yes. Any doubt regarding this upcasting and downcasting?
No, sir. No, sir.
Casting is nothing. Downcasting, actually, I thought of explaining this concept before dynamic cast only. I forgot about that. So, is there any in detail explanation about this downcasting means? Just because of this only, to handle this downcast runtime, we approached with downcast operator, like a dynamic cast operator. So, how we used that dynamic cast, how we handle that exception of dynamic cast. That's it. This is about upcasting and downcasting. I will share you this code later.
Yes, sir.
Yeah, good. Now, students, I'm moving to the next new concept. Next unit is STL part. And one more thing, students, STL. Yes, first let me start this. Today I will tell you only theory about this STL. What is the full form of STL? STL, anyone knows? STL. Standard Template Library. Yes. It is Standard Template Library. In short form, we can call it as STL. See, STL standard template library. STL is nothing but it is standard template library. So knowingly, unknowingly, we are using libraries, different libraries. See what we are using now. We are using IOStream. It is one of the library. Type info, correct? IOStream. We are using all different types of like few different types of libraries. But here under this STL, what it contains? What is this STL? See, STL is actually C++, especially this is C++. It is providing built-in library. It is providing, it is a built-in library. STL is it is a built-in library in C++. In C++. So we can call it as, it is a collection of, but I will tell you theoretical about this. It is a collection of header files. It is a collection of header files. You know very well about the STL means. You can tell me, sir, it is a collection of files. And alternatively, we can call it as like, it is a collection of built-in is collection of built-in classes. This collection of built-in classes. So here, so what is STL? STL is nothing but it is a standard template library. It is a built-in library in C++. Built-in library in C++. So we can call it as like STL is nothing but it is a collection of header files. Parallelly, it is a collection of built-in classes also. It is a collection of built-in classes. So why we go with this STLs? I will tell you orally. See, till now we have written many programs. Am I correct or not, students, in C++? Students, are you there?
Yes, sir.
Yes. We have written many programs. See, what we were doing in those programs, we define variables, correct? You can define classes. We can define objects. We can create objects. Am I correct or not? This is what we did in C++. So in high level, am I correct?
Yes, sir.
Yes. Very good. So now, parallelly along with this advanced C++ subject, you people are learning data structures. Am I correct?
Yes, sir.
Yes. So in one coin of the side, you are studying this C++, advanced C++. In another side, you are learning data structures with the C++. So in my subject, I'm not using any concept of data structures, but in that subject, you are using data structures. You please tell me, what is the use of data structure? Tell me, students. What is the use of data structures?
Sir, organizing our data into more efficient structures.
Organizing data into more efficient structures. Okay. Next. Very good. That's valid point. Any other? Students, Students, tell me any other.
So, Shorage is keeping something in chat.
Okay, he's writing in chat box.
So,
Yes, to store data in a way that finding data easier and faster. Very good. To store the data in a way that finding data is easier and faster. Very good. That is also valid point. Next. Next. Please tell me.
Sir, to reduce time complexity.
That's another. Just what I am asking you. Just you tell me the importance of data structures, why we must use. Why we must use the data structure. Tell me. Better code readability. Next.
Sir, reusability.
Okay. One. Yes. Yes. Of course, I think you observed or not, you are now you are learning a data structure. If you go like not in a C++, normally, even though when you studied in C also, data structures are classified into two types, correct? Correct or not? Data structures are classified into two types. One is linear data structure and second one is non-linear data structure, correct?
yes, sir.
Linear, non-linear. Because students, why I'm explaining this concept very slowly means it is very, very important because STL is totally it's made up of data structures only. At the same time, you are studying data structure. This is very, very important. So now in C, data structures are normally data structures are classified into two types. One is linear and non-linear. You please tell me what is a linear data structure? What is linear data structure? Students, tell me in generic way. You please explain me.
Sir, like array is a linear data structure.
Array is the linear data structure. Okay.
Linked list.
Okay. Okay. Linked list. Next.
Sir, anything that is continuous.
Continuous. Okay. So linear data structures are you can take basic one is array. Other than this, so we have linked list. Stack is a one data structure, correct?
Yes, sir.
Again, many others will come. Linked list means different types are there. When you go to the non-linear data structure, only two are there, correct?
Yes.
I think Madam is explaining you those concepts. I don't know. Trees and graphs. Okay?
Yes, sir.
Trees and graphs. These are the non-linear data structures. So finally, if you don't have data structure, I'm explaining you. If you don't have any data structure, when you start discussing about arrays, then only you will get n number of values, correct? Correct or not?
Yes, sir. Yes.
Array of integers means you will take 10 integers. Array of character means you will get 10 characters, correct? Same thing when you start implementing stack. you will get more than one element, correct?
Yes.
Queue, more than one element. Linked list, more than one element. Again, linked list, single linked list, double linked list, circle linked links, more than one element. When you take tree consists of nodes. Each node contains some element. That is also nothing but n number of elements, correct?
Yes.
Graph contains also, it's like a graphical representation. It is also having n number of elements. If you observe these concepts, arrays, linked list, stacks, queues, graphs, trees, we are not going to take only one element. We are going to take n number of elements. Why we are taking n number of elements means that is very, very important here. In today's market, in today's trend, we need to store the information like that. For example, if I want to store hall ticket numbers of your batch, you people are almost all 45. Okay, correct? I can use an array for index of 45. I can store all your hall ticket numbers. Am I correct or not?
Yes, sir.
That means whenever you want to store data means not single data. Okay, like you have some quantity of data. In those cases, you must use data structures. If you don't have data structures concept, you cannot store like that. Am I correct? You please tell me, if you don't have array, you want to store 45 hall ticket numbers, what you do? Anyone now?
Make array for 45 elements.
No. Aditya, if there is no concept of array,
Okay.
if there is no concept of array, how we will store 45 students hall ticket numbers? Tell me.
We have to make 45 variables.
Yes. You have to create 45 variables to store hall ticket numbers, correct?
Yes,
Store
sir.
45 students' names. To store 45 student names, you need to create again 45 string type variables, correct? Am I correct or not?
Yes, sir.
Yes, sir. See, to store only name and hall ticket numbers without the concept of data structures, we need to declare and define 90 variables. Correct?
Yes, sir.
Yes. See, unknowingly, we are using arrays. But if you go in depth of why we are using arrays means this is the basic concept. So, when you start writing, implementing data structures, you must know one thing. What is that? Yes, we are going to handle data, that is n data. So, collection of informations. Am I correct?
Yes, sir.
Yes. Because of that reason only, we are using data structures. Now imagine in today's market, if you take any application without concept of these data structures, it is not possible. Correct?
Yes, sir.
There is an organization, 10,000 employees are there. You want to store 10,000 employees' information, you must use data structures. Yes, other than data structures, you can implement it, but it's very complicated. You cannot handle it. That's why slowly they started adding these data structures concepts to the normal concepts. So finally, we come to know importance of data structures. Now you are doing data structures. Now, to store the collection of values means collection of hall ticket numbers. What you do? Minimum data structure is, what type of data structure you use? You want to use collection of values. We use data structures, correct? I want to store collection of values. Students, anyone is having doubt regarding this, you please ask me. Because you must... tell me, someone is asking me. anyone is having doubt regarding this, you please ask me, because we will, from next class onwards, we will start implementation of all these things programmatically. Collection of values, definitely we need data structure, correct? Will you accept this? We want to store
Yes, sir.
collection of values, we must use data structure. So data structure is nothing but is collection of data, correct? But here, if you go in depth of this, whenever you have collection of data, collection of values, we must take care about the data. How we are organizing that data, that is very, very important, correct? Here, we need to organize data properly. Am I correct? Organize data in an efficient. Will you accept this point or not? Whenever you have a collection of data, we need to organize it in efficient. So I will tell you one example. See, you have one pair of shoe. You have one pair of shoe. Only one pair. Then there is no problem. Even if you don't organize that pair, you can find it because only one pair is there. That's it. Whenever you have 10 pairs of shoes. Hello, students? Getting my point?
Yes, sir.
10 pairs of shoes. If you don't organize properly, you come to know. See, most of the students are having more than 2 or more than 3 pairs. If you don't organize those pairs, whenever you get ready for the college, if you don't organize properly, you can find left shoe, you cannot find right shoe of one model, like that. Am I correct? If you don't organize properly, just imagine if you have 100 pairs of shoe. If you don't organize properly, it is very bit difficult. Am I correct or not? Will you answer
Yes, sir.
this one? Yes.
Very difficult.
See, there is no problem if you have n number of data, collection of data. The problem is that whenever you have more data, collection of data, the major thing is you need to organize the data properly. Then only you can get the data very easily. So, organization of data in an efficient way is very, very important concept. To do that, we have different types of data structures, algorithms. Am I correct or not?
Yes, sir.
Yes. So here we have, simply you can use array is a one data structure to store this collection of values. That is, if you want to store hall ticket numbers or marks, you can use array. So array is, I know you people are doing stack implement. Students, have you implemented stack with arrays?
Yes, sir.
Yes,
Yes.
okay, no. Yes. You can create a space like statically, dynamically. You know very well about that.
Yes, sir.
Yes. So now here, you please tell me. See, there is a one array. Just I'm taking this. There is a one array. Sizes. You declared that it is a 10. Size is 10. What does it mean? It can store 10 items or 10 elements, correct? Hello?
Yes, sir.
Yes. Now, you think that you stored 10 elements. Just already I have stored 10 elements or 10 values. Next, whenever I want to insert like few more elements, more values. It's already full. Array is full. That means you can take the stack is full. Array is full. Then I want to insert two more values. Is there any possibility?
No, sir.
Why?
Because it is full, sir.
It is already full. Correct? So that is the basic reason is it's already full. If you increase it, if you want to store some other values, you will get an error. Correct? So that means we cannot store. If you handle it all those exceptions based on the limitation, you can show you messages to the user also. So here the major thing is whenever you use array, normal array, we cannot increase. Have you seen this kind of situation in normal arrays? So we cannot, will you accept this or not? You please tell me. We cannot increase or decrease. We cannot increase or decrease the size of the array. The size of the array dynamically. Will you accept this or not?
Yes, sir.
Yes, sir.
Yes. See, we cannot increase it. We cannot decrease it. We cannot increase it or we cannot decrease it. See, once you use 10, it's fixed. If you use 10 means there is no problem. If you use 5, yes, remaining for 5 values, it is there only. Even though it is empty, it will be there. But if you want to exceed it, if you want to give extra, no, there is no problem. There is no any solution. We cannot increase or we cannot decrease the size of the array dynamically. That is the major drawback. This is the major disadvantage of an array. Correct? For example, sir, why sir, I will take, instead of that, I will take 10,000. Size of the array is 10,000. But you are storing only 1,000 values. What about remaining 9,000?
Waste of space, sir.
Waste of space. No, as a good programmer, sir, you are telling that this is the problem. Why I should take this problem? I initialize that array with 10,000 only. But you have employees for only about 2,000. What about remaining 8,000 means? So it is like what you are doing, you are misusing of that memory, correct? It doesn't make sense. So if you do like this, a lot of spaces gets wasted. Correct? Correct or not?
Yes, sir.
Majorly in data structures, what you do, if you are doing this data structures. So what data structures you finished till now, students? Tell me.
There are linked list, queues, stacks, little bit of trees.
Okay. Yes. These are the data structures you have studied till now. Okay. So now you know data structures. I will tell you one point. You only should tell is it correct or not. Most frequently operations we do in data structures are is it correct or not?
Yes, sir.
Yes, sir.
Adding or deleting. This is the operation. Whatever you do with the data, you are working with the data structures. Means we add something or we delete something. Am I correct?
Yes, sir.
Yes. Here this is very, very important. If the data structure is fixed, you cannot insert more elements, correct? And sir, I declared one array with 10,000, but I am using for only 1,000 means. Will you delete remaining 9,000? Tell me. You cannot delete it. Am I correct?
No,
Yes,
not possible, sir.
Yes, it is not. See, you cannot increase it. You cannot delete it. Finally, what is the problem inside this? Am I correct? Will you accept this?
Yes, sir. Yes, sir.
Correct? Yes. So now we need to handle this problem with space dynamically. Problem with space dynamically. See, how can we handle dynamically means, I will tell you. So that's why in STL, it is a made up of data structures. I am telling you, STL is nothing but it consists of I showed you only one problem. What is with the normal data structures? What problem we have means problem with space. This is one problem. If you go in detail, we have some other problems are there. So everything should be dynamic, correct? If you increase the element, automatically it has to increase the size of the array. If you decrease it, automatically it has to remove the wastage. If it is like this, then it will be more optimal. Am I correct? So STL is a consists of data structures. So what data structures it is having? Same thing, whatever you discussed. So whatever you discussed in data structures, all concepts we will discuss here only. So that's why here. And one more thing I will ask you students. You please tell me length of the code you have written for stack. What is the length of the code? Already written code, no? Arrays. First you tell me to declare and define array for 10 elements. Insert whatever you do. How many lines of code it requires? It's normal array to store 10 elements.
3 to 5 lines. So 3 to 5 lines.
Okay. Next, implementation of stack with arrays. I think you have written code now.
Yes, sir. Wait a second, sir.
Tell me just lines of code. Tell me, students, others. You are writing code now for stacks, queues, single linked list. You take any data structure, just lines of code.
So like to create the data structure, just to store.
No, everything. To handle everything, insertion, deletion operations.
50 to 60 lines.
Correct. You take 50 minimum. See here, if you take stack, queue to do all these operations like insertion and deletion, again insertion, many cases will be there, insert at begin, insert at middle, correct? Many are there. So what you have to do as a programmer, we need to write code for array or stack or queue. Am I correct or not? Normally, you only telling that minimum 50 lines of code will be there. That means who is writing the code? Who is writing?
Programmer, sir.
Programmer only has to write down the code. But whereas when you start using STL, but C++, see, you can write down data structures with C also. Whereas in C++, it provides, a built-in library for all these programs as a collection of classes. As yes, please see this. Normally in C, you are writing data structures with C means programmer, you have to write down the code for arrays, stacks, queues, linked lists, trees, graphs, and everything. But whereas when you are implementing data structures with C++, but in C++ also you are writing whole code as a programmer, you people are writing that code, correct or not? Hello?
Yes,
Correct
sir.
or not?
Yes, sir.
But in C++, it is having additional functionality. What is that? STL. What is the use of STL means? STL is a built-in library. It is having already built-in code for all these like array, stacks, queues, graphs, and trees, and everything. Okay.
Yes, sir.
Yes, sir.
Okay. So that means, which is a built-in library for all these programs as a collection of classes, STL. That means here just you need to include that class. You can create a array, or you can create a stack, and you can add elements, and you can delete elements. That's it. Whatever you write 50 lines, 60 lines of code in normal data structures without STL, with STL you can do it within with the help of 2 lines, 3 lines only. Understood this line?
Yes, sir.
Yes, this is a small introduction about STL, students. In next class we will continue with this. Okay, understood why we go with STL?
Yes, sir.
Yes, sir. Yes, sir.
Yes, this is the main objective of using STL. Just here we will not write like some n number of lines for all these data structures, but names are different, students. Don't think that we have same names in STL. We have some other names. So here we are reducing, we are not, as a program, we are not writing whole code for implementation of all these data structures. Just we include those classes. Just every class is having already defined functions. With the help of defined functions, we can add, we can delete, we can do some operations. When we start discussion about all those programs, then you come to know. Okay?
Okay, sir.
Any doubt regarding this?
No doubt, sir. No, sir. No, sir.
Clear now?
Yes, sir. Yes, sir. Yes, sir.
Yes, yes. You please wait, students. I will take your attendance. Answer attendance. Shaurish. Advait. 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 Suhas. Anushri. Anushri. Arosha.
Present, sir.
Balsubramaniam. Dipanshu.
Present, sir.
Devashish.
Present, sir.
Lalit. Lalit.